Family number 3 is halogens. Now I'll be forced to draw a very small periodic table here. Halogens. We said it has 8 columns because of 8 groups. 1, 2. This is shaded. 1, 2, 3, 4, 5, 6, 7, 8. This one not that patrician. This is hydrogen. This is helium. I won't name all of them. Hydrogen, helium, medium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. So we are talking about fluorine here. Neon, sodium, magnesium, aluminium, silicon, number 14. Number 15, phosphorus. Number 16, sulfur. Number 17, chlorine. These are what we are talking about. Group 7 elements. Group 7 elements, and they are called halogens. Yes, they are called halogens. Halogens. The ones among the first 20 elements are only fluorine and chlorine. Fluorine and chlorine, number 9 and number 7. Oh my god. Number 9, yes, and number 17. The two of them. Others which do not belong to the first 20 elements include iodine, bromine, and astatine. So there are 3 more halogens not among the first 20 elements: iodine, bromine, and astatine. Iodine and bromine are mentioned in chemistry at high school level for uncountable times. Iodine and bromine will be there now and then. Astatine, we'll be mentioning it here and then leaving it at that. Fluorine, chlorine, bromine, that will be the third element in this group. Bromine, iodine, atomic number 53, astatine, and another one here. Its symbol is UUS. Okay, these are halogens. Now we'll be looking at the same properties, but maybe we'll make some few changes. The first property is the energy levels. Let's go straight to it. Energy levels. Halogens. The first one is number 9, fluorine. Fluorine is number 9 with a configuration of 2 and 7. 2, 7. So that is the nucleus of fluorine. 2, 7. 2 and 7. 1, 2, 3, 4, 5, 6, 7 to make 9. And then we have chlorine. Chlorine is atomic number 17, configuration 287. Let us draw it. 3 energy levels. Chlorine 2, 8, 7, 2, then 8. 1, 2, 3, 4, 5, 6, 7, 8. That energy level is now full. And then 7. 1, 2, 3, 4, 5, 6, 7. And now since we have the atoms, we can now start discussing these properties. And the first property is the number of energy levels. We have talked of fluorine 2, 7, and we have talked of chlorine 2, 8, 7. Fluorine has 2 energy levels. Chlorine has 3 energy levels. In short, energy levels increase down the group. Still about down the group, increase down the group. Increase down the group. Yes, that is the number of energy levels. So we expect, we have said just that number 53 is it 53? Bromine is 35, so it has more energy levels. Iodine is 53. It has even more energy levels. So the number of energy levels increase good down the group. We can now check on the atomic radius and the ionic radius and then compare them. Okay, we start with the atomic radius. The distance from the center of the nucleus to the edge. For fluorine, from the center of the nucleus to the edge, that will be the radius. The same case to chlorine, from the center of the nucleus to the end. The atomic radius of chlorine, since it has a higher number of energy levels, the atomic radius is big in chlorine as compared to fluorine. And hence we conclude that the atomic radius increases down the group. It increases down the group. The atomic radius increases down the group for halogens, group 7 elements. So bromine, iodine, astatine, they even have larger atom size. That is done. Let us compare the ionic radius. Ionic radius, we said that fluorine is 27 and chlorine is 287. Potassium was 2881. And we said that for potassium, it easily loses an electron, because for it to be stable, it either have to gain 7 so that it can have 8 energy levels in the last 8 electrons in the last energy level. It has either to gain 7 or lose 1. It loses this one so that they can attain the octet state of 8 electrons in the last energy level. It is easier to lose 1 because a lot of energy will be required to gain 7. Now, this one is not the case in halogens, because a halogen now has 7 electrons in the outermost energy level. It has 7 electrons in the outermost energy level. Therefore, it either has to lose 7 or gain 1. Either lose 7 or gain 1. And it holds even here. It will require a lot of energy to lose 7 electrons. And therefore, it gains 1 electron. To gain stability, it gains 1 electron. That one was said in ion formation, earlier structure of the periodic structure of the atom. Yeah, structure of the atom. It is said that it easily gains 1 electron. In short, it has to gain 1 electron. The same case to this one, it has to gain 1 electron. So we can draw the ions. Yes, let us draw the ions. So fluorine, it will have the same number of energy levels. This is 27. It gains 1 electron to have a configuration of 2,8. The ion will be, this is fluorine ion, let me draw it here. Fluorine, I said it is 2 and 8. 2 and 8. 1, 2, 3, 4, 5, 6, 7, 8. Again, the electron. That will be fluorine. Chlorine here. Chlorine, it gains 1 electron to have a configuration of 2, 8, 8. Chlorine, 2, 8, 8. 8. 2 and then 8. 1, 2, 3, 4, 5, 6, 7, 8, and another 8. 1, 2, 3, 4, 5, 6, 7, and again the electron 8. So in this case, the atoms and the ions both have the same number of energy levels. Yes, they have the same number of energy levels. Fluorine atom 2, fluorine ion 2, chlorine atom 3, chloride ion 3 energy levels. We have just talked of the number of energy levels down the group. We see the increase. Now we are at atomic radius. We talked about it. It also increases down the group due to the increase in the number of energy levels. Now we want to talk about the ionic radius. of this and this. Now, and whatever I say now, the same knowledge I'll be using, the same knowledge I'll use when we are discussing trends in period 3 elements. The same knowledge I will use when we discuss trends in period. So I'll mention it here, but I will refer to it when I come to that point. And we are saying that this is for, let us use chlorine. This is chlorine ion, this is chloride ion. Chlorine ion has a configuration of 287, and chloride ion has a configuration of 288. So this chlorine atom at the center, it has 17 protons or 17 positive charges, 17 protons, and then the shell, the energy levels got 17 electrons. So 17 protons, 17 electrons. Therefore, the charges are balancing. We have the same number of protons as electrons. And this attraction is one we are calling it nuclear attraction. The attraction between the positive charges and the negative charges in the energy levels. And that is the chloride ions. We want to see how these ones will be affecting the size of the ion. How it will affect the size of the ion. Now, it has gained an electron. Yes, it has gained an electron now. This one, it gains an electron. Now, how will the ion look like? The charges. The ion will be like this. We will have chloride ion. At the center, the number of protons does not change. You see, the number of proton is the atomic number of the element. So it remains constant all through. It has now 17 protons. But now it has gained one more electron. So there were 17 protons. Now we got 18 electrons. Yes, it gained one to be in octet. We have 18 electrons and 17 protons. This one was 17, 17. They were balancing. Now what happened? When there was introduced a new electron, the number of negative charges became more than the positive charges. The number of negative charges became more than the number of positive charges. And what did it mean? Now, this one was pulling or attracting 17 electrons. Now this one is attracting 18. It becomes like a load. This one is attracting, it has 17 protons but attracting 18 electrons. And therefore, the nuclear attraction becomes less. Yes, the nuclear attraction is lessened, becomes less. The nuclear attraction here, it becomes less because it is pulling more electrons than before. And when it becomes less, when it becomes less, it means that the atomic radius, the radius now has increased. Yes, the radius has increased. This is for the first time the ion now has a bigger ionic radius than the atomic radius. This element. For these cases, we saw that both atoms, in both cases, the atom size was bigger than the ion size. The atom size was bigger than the ion. The atom size was bigger than the ion because of the number of energy levels. Now here there is no change in number of energy levels, but due to the introduction of negative charges, we now have the nuclear charge that was being used. The number of positive charges are the same, but negative charges have increased, and therefore there is low attraction. The nuclear attraction is now low. Imelegea. Ikilegea kunaendelea nini? It translates to the size of the ion increasing. The size of the ion increasing. So it will be a bit different to period 3, but the size of the ions increases. So what now do you conclude? Because it is these ones that are pulling electrons. Now they have a bigger load to carry. The ion is now, the electrons are now more, and therefore the ionic size is smaller. The ionic size is bigger, yes, bigger. So let us conclude about the sizes of atoms and ions. Oh, so we first say, what about the ions? Before we compare the atoms to the ions. The ions, this is the ion of fluorine, which is the fluoride ion. This is the ion of chlorine, the chloride ion, the chloride ion, the fluoride ion. Chlorine is obviously, and it can be seen that it is bigger than the fluoride ion, and therefore the size of the ion, the ionic radii of halogens, the ionic radii of halogens increases down the group too. It increases down the group because of the increase in the number of energy levels. In this case, we say because of the increase in the number of energy levels. Fluoride ion, chloride ion, the ionic radius increases down the group due to the increase in number of energy levels. This one has 2, this one has 3. We have looked at the atomic radius. Good. We have looked at the ionic radius. Now we want to compare them. Let us compare the taking of a single element like chlorine. Let us compare the atomic radius and the ionic radius. And we have already discussed and said that there is an increase in the number of negative charges leading to lower nuclear attraction. And that is it. But the thing is, which one is bigger? Is it chlorine ion? Sorry, is it the atomic radius or the ionic radius? The bigger one is the ionic radius. Yes, it's ionic radius. So you have been told now compare the ion of chlorine to its atom. Sorry, compare the atomic size of chlorine to the ionic size of its ion. So you say that halogens have ionic radius bigger than the atomic radius. Yes, that is the statement. We have just stated it. Halogens have ionic radius bigger than the atomic radius because the ions are formed by losing, by gaining electrons. Ions are formed by gaining electrons. Chloride ions will be formed by a gain of an electron that reduces the nuclear charge. Reduces the nuclear charge. Yes, we reduce the nuclear charge. That is complete. Which reduces the nuclear charge, and that one is the one that will bring about them having ionic radius bigger than the atomic radius. So it was such a challenging concept, but we tackled it to the end. So we have looked at this part. Atomic radius, we have just looked at it. Now we go to the ionization energy.